In this video, we'll be adding and subtracting unlike radicals. As mentioned in the previous video, you can only add and subtract radicals that are like. So the first thing we want to do is simplify radicals that were given to see if we have like radicals. So you start by simplifying each radical, and then you add or subtract the ones that are like. So let's subtract square root of 32 minus square root of 50. The first thing we want to do is simplify each radical. So we want to start by looking for the largest perfect square that's a factor of 32. The largest perfect square is 16. This is the square root of 16 times the square root of 2. And we know the square root of 16, that's just 4. So here we have 4 square root of 2. And then I want to simplify the square root of 50. Again, we're looking for the largest perfect square that's a factor of 50. 25 goes in 2 times. So this becomes the square root of 25 times the square root of 2. And we know the square root of 25 is 5. So that simplifies to be 5 square root of 2. We now see that we have like radicals, and we can subtract. 4 square roots of 2 minus 5 square roots of 2 leaves us with negative 1 square roots of 2. And you could just write negative square root of 2 if you really wanted. Either one, same thing. Go ahead. Let's take a look at one where not only do we have to simplify the radical, but there's a number out in front. It's just important that you don't forget about that number out in front. So starting with 6 square root of 75. Remember to continue to bring down this 6. We're looking for the largest perfect square that is a factor of 75. That would be 25. We can break this up into the square root of 25 times the square root of 3. And we know the square root of 25, that's just 5. So we've brought down the 6, so it's going to be 6 times 5 square root of 3. So that's going to be 30 square roots of 3. Now we want to simplify 5 square root of 48. I'm going to go ahead and write my minus down here at the bottom so I don't forget about it. Remember, I'll be bringing my 5 straight down. Simplifying the square root of 48, we want the largest perfect square that's a factor of 48. Well, that would be 16, goes in 3 times. So we have our 5 out in front times square root of 16 is 4, square root of 3. This simplifies to 20 square root of 3. Now we have 2 square roots of 32. I'm going to write my plus down here. I won't forget to bring my 2 down. And now I'm looking for the largest perfect square that's a factor of 32. That's going to be 16, goes in 2 times. So I have my 2 out in front. Square root of 16 is 4. And then we have the square root of 2. This simplifies to be 8 square root of 2. Now that I've simplified all my radicals, I want to combine any that are like. You'll notice in this example, all the radicals are not like. Only these ones are. So guess what? We're only going to combine the ones that are like. 30 square roots of 3 minus 20 square roots of 3 gives us 10 square roots of 3, and we just bring down the plus 8 square root of 2. Now let's take a look at some examples that have both numbers and variables in it. It's still the same procedure. We're going to simplify, see if we have like radicals, and then combine the ones that are like. It's just we have to now simplify radicals that have both numbers and variables underneath. Starting with 2b square root of 12a to the third b. I'm going to remember to bring my 2b down, just like in the other examples. And since I have both numbers and variables underneath of my radical, I'm going to break it up into two and look at them separately since our simplifying technique is different. So with the square root of 12, I'm looking for the largest perfect square that is a factor. That's going to be 4. So this is the square root of 4 times the square root of 3. Get my original 2b out in front times square root of 4 is 2, and then we got the square root of 3. And now I need to simplify the variable portion. We're dividing our index of 2 into our exponents. So 2 goes into 3 one time. So that's a to the first on the outside with a remainder of 1. So that's a to the first underneath. The exponent on b is 1. 2 does not go into 1. Remember, if the exponent is smaller than the index, that is not going to simplify. So that's just b underneath. So let's clean all this up. We want to multiply everything that's outside of the radical together and everything that's underneath the radicals. Let's put it into a single radical. This becomes 4ab times the square root of 3ab. Now let's do the other one. We need to simplify a times the square root of 192ab to the third. I'm going to remember to bring the a out in front down. I'm going to break this up into the square root of 192 times the square root of ab to the third. We want to look for the largest perfect square that's a factor of 192. That's going to be 64, goes in 3 times. So here's my a out in front, times square root of 64 is 8, square root of 3. And now we want to address our variables under our square root. The exponent on a is less than my index, so I know that can't be simplified. I'm just going to have a underneath. But with the b, it's greater, so there should be some simplifying. 2 goes into 3 one time. That's b to the first on the outside. And then we have a remainder of 1, so that's b to the first underneath. Let's clean this up. Outside, we're going to have 8ab, and then underneath, 3ab. Once we've simplified, we want to look and see, do we have like radicals that we can combine? Yes, we do. Same index, same radicand. So all we need to do is subtract the coefficients. So 4ab minus 8ab gives us negative 4ab, and the radical stays the same. We get a final answer of negative 4ab square root of 3ab. Please note that if the 4ab and the 8ab were not like terms, we would not be able to combine it in this way. We would have to do some factoring and it becomes more complicated. In this course, you should have like terms on the outside as well. One more example, 3 radicals that we're adding and subtracting with variables and numerical radicands. Please note that these are cube roots. Those are not exponents. That is an index of 3 on each of the radicals. We want to start by simplifying x times the cube root of 16y to the 4th. I'm going to remember to bring my x straight down. I'm going to break this up into the cube root of 16 and the cube root of y to the 4th. We want to simplify the cube root of 16. We look for the largest perfect cube that's a factor of 16. 8 is it? So this becomes the cube root of 8 times the cube root of 2. So here's my multiplication by x out in front. Cube root of 8 is 2. Then we have the cube root of 2, and we want to simplify our variable index dividing into our exponent. 3 goes into 4 one time with a remainder of 1, so we get y cube root of y. Let's clean this up. Everything on the outside together, 2xy, everything underneath one radical, cube root of 2y. Next, let's simplify 4 times the cube root of 54, x to the 3rd, y to the 4th. I'm going to remember to bring this 4 straight down. It's so common that people forget about whatever's out in front, which is why I like to make the big arrow so that I don't forget it. It draws my attention to it. Let's break this up into the cube root of 54 and the cube root of x to the 3rd, y to the 4th. I'm looking for the largest perfect cube that's a factor of 54. It's going to be 27. This is the cube root of 27 times the cube root of 2. Here's my multiplication by 4 out in front. Cube root of 27 is 3. And then we have the cube root of 2. We want to simplify our variables. 3 goes into 3 one time, so that's x to the 1st on the outside with no remainder. 3 goes into 4 one time with a remainder of 1, so that's 1y on the outside and 1y on the inside. Cleaning up what we have, multiplying what's on the outside, we get 12xy. Putting everything under one radical, cube root 2y. One more to simplify. Xy times the cube root of 250y. I'm going to remember to bring the xy straight down. I need to simplify the cube root of 250 and the cube root of y. To simplify the cube root of 250, we look for the largest perfect cube that's a factor. That'll be 125. That goes in 2 times, so we get the cube root of 125 and the cube root of 2. Here's my multiplication by xy that I bring straight down. Cube root of 125 is 5. Then we have the cube root of 2. Then I want to simplify the cube root of y, but the exponent on y is less than my index, so I know I can't simplify that. I just bring it down. Cleaning this up, everything on the outside, that's 5xy. Everything underneath, 1 radical, cube root of 2y. I've done all my simplifying, and now I want to check for like radicals, and I do indeed have 3 like radicals. I can add and subtract my coefficients and then bring the radical right down. So 2xy plus 12xy, that's 14xy, minus 5xy We're going to have 9xy outside, and then my radical stays the same. We get a final answer of 9xy times the cube root of 2y.